All right, so let's look at some examples of games then. The first game that we're going to look at is a game that's not really particularly fun to play, but it's more of a thought experiment in this case. And it's called The Prisoner's Dilemma. The Prisoner's Dilemma is basically set up that there are two suspects. They're both arrested by the police, and the police don't have enough evidence for a conviction, particularly conviction of both. So what they do is they separate the prisoners, and they visit each of them separately and offer them a deal. If one of them testifies against the other, and the other one remains silent, then the person who betrays goes free, and the silent accomplice gets a 10-year prison sentence. If both stay silent, then they're both sentenced to 6 months in prison for a minor charge. And if they both betray the other, then they each get a 2-year sentence. Now, the prisoner's dilemma is, I mean, it creates this sort of obvious awareness that if you look at this, regardless of what your opponents or regardless of what the other suspect does, it's always to the advantage of the player to betray the other player. So if you're playing the prisoner's dilemma once, you should always betray. The prisoner's dilemma, well, let's look at it in terms of game theory. Game theory is a branch of mathematics that can take and basically dissect a game and determine like the victory conditions. So in looking at this chart, we see that regardless of what happens, if you're prisoner A, you end up doing less time if you betray prisoner B. But however, if you look at this as like sort of a total of the amount of time served by both prisoners as potentially a cooperative game, the best outcome is for both players to remain silent. So what this amounts to then is that since the best strategy is always to betray the other player, the prisoner's dilemma really needs to be played more than once. If it only really makes sense if you know that you're going to be playing it. Maybe you don't know how many times you're going to be playing it, but the first time you play it, then if you betray, then you may end up getting like some sort of revenge betrayal back on you. The best way to sort of solve this game is to start to work with the other player and to minimize the amount of time that is served. So, as I said, the sentence is always lower if you betray, but over the long haul, then, as you iterate through the game, working cooperatively actually lowers the amount of time spent in prison. Now, the prisoner's dilemma is, I mean, it just definitely doesn't feel like a very good game. It's not very exciting or interesting, even if you are playing it multiple times. But it actually models some real life conditions. For example, in the law, plea bargains are not permitted in certain countries. And that's because it's always to the benefit of a person who is arrested with somebody else to implicate the other person, whether or not that person is guilty or not. So you'll always end up with a lesser sentence if you say, oh yes, and somebody else is guilty too, and so therefore I want to reduce my sentence. And this giving up of the other person, even if they're innocent, then is like, it runs counter to the idea of justice. So also another example would be like in the terms of like an arms race. It is to the advantage of any particular country to expand militarily, all right? And so you end up balancing the military expenditure versus an agreement to reduce weapons. Now, and spending sort of based on that. So if both countries determine to reduce weapons, then they both benefit economically. If one country increases its military and is able to then invade the other country or take over a certain amount of land, then it obviously benefits from expansion. The end result, though, is that both countries end up with higher military expenditures, and this is an irrational result. They're investing in something that they never end up using. So I want to point out that I have just lost the game, and you have too. The game is an insidious little mind game that was created and is banned in certain areas because it's so troublesome. The rules of the game are very simple. You are always playing the game, whether you agree to it or whether you disagree to playing the game. You are always playing. Whenever someone thinks about the game, they lose. When you lose, you need to announce that you've lost to at least one other person. And the previous slide actually had some information on losing the game. There are some very significant strategies in getting other people to lose bigger than you lose. And so there's no real winning the game. It's much more about causing other people to lose, or causing more people to lose by losing yourself. Rock, paper, scissors is a pretty common game. I think we all pretty much understand it. It's like 1, 2, 3. Choose rock, paper, or scissors. Scissors beats paper, beats rock, which beats scissors. It's a fair game. Each sign will beat one other sign and is beaten by one other sign. So it's pretty much an even comparison. Beyond that, it's also a game of skill. And if you think about it, you think, well, wait a minute, it feels like it's kind of just random. If you have two computers playing against each other, rock, paper, scissors, it is pretty random. But with people, we have these things called tells, where it's like it's possible to read your opponent's move before they make it. People don't make random moves. And I can essentially prove that rock, paper, scissors with people is a game of skill by pointing out to you that there are rock, paper, scissors tournaments. And the people who win fairly consistently. And that wouldn't be possible if it was just a random game. So there have also been several famous rock, paper, scissors matches. You may remember World War II, where Churchill used his scissors to handily beat Hitler's paper. Or the late 60s, where Black Power threw rock and the hippies threw scissors. Now, that's sort of a playful kind of interpretation of the game of rock, paper, scissors. But the reason that that's possible is because the gestures are very common. Taking and sort of expanding on this and creating yet another fair game, we have rock, paper, scissors, Spock, lizard. Now this has 5 signs in it instead of 3. But if you look at this diagram, you'll see that this is also a fair game. Each sign is beat by 2 signs, and each sign beats 2 other ones. So scissors cuts rock, covers paper, crushes lizard, poisons Spock, smashes scissors, decapitates lizard, eats paper, disproves Spock, vaporizes rock, crushes scissors. And this game is more challenging just from the standpoint that we all know and understand rock, paper, scissors and can sort of process those signs much more easily. But this one has a much more complex diagram to it.